use it in the future. But then that's data I'm collecting. So data are raw facts. They are raw. Like I said the last time, they can't necessarily be used like that in the state they are. You can't necessarily consume them like that in the state they are. They are raw as possible, right? You know, when they make alcohol, like it's said that it's very concentrated. So you have to put in some processes into it, like to get it to the point where people can drink and it doesn't harm them or anything like that. So data is like that too. Data is raw at birth, very raw. So data can be numbers, can be words, can be measurements, can be observations, or even description of things. Yes, descriptions of things can be data. All of these things data can take as any form that we can think of. It could be numbers, it could be words, it could be measurements. You could take a thermometer and take somebody's temperature. That's you are collecting data. You could count things. You count dogs, you count cats, you count bags of rice. You do all of those. You are collecting data. You are performing an observation. So data can
So
do
it's
all
not
those.
showing again.
It's not showing again.
Yes, the screen.
Okay, let me check. Is it back now?
Yes, it's showing now.
Good. So there are four main categories. When we're talking about data, we're looking at four main categories. We have nominal, ordinal, discrete, and discontinuous. So I will talk about all of this in a minute. So, but then why I brought you this way is that understanding data actually helps you a lot. Many people just dive into it. They just get themselves into Microsoft Excel and just start doing things. But while I don't know, it's fine for them. Maybe they learn genius level. It's fine. But then to really understand the rudiments, you need to come this route, right? You need to understand. If you don't know data, you don't know how to work with it. If you don't know data, you don't know the best way to work with it. If you don't know data, you don't know a lot of things about it. You just do things because people are doing, right? So somebody could come and say, I'm an analyst. Ask the person some basic questions. They can't necessarily answer because most people just dived into, okay, let's start using Excel, let's start using, but everything that needs to be learned before going into that, you just keep it. So that's not the best way to learn. It's better you learn the foundations. You have a solid one, then you can start building on whatever you have by yourself. Not bringing the roof when the foundation is not solid. Okay. So basically, there are two types of data. When we talk about data, we have two types. We have quantitative data and we have qualitative data. Now, on the first slide, I said there are four of them. Yeah, there are four, but then those four are grouped under these two. So we have two under quantitative data, we have two under qualitative data. So that was not entirely wrong. So two types of quantitative data and two types of qualitative data. So in the end, we have like four. Okay, for quantitative data, when we're talking about quantitative data, right, we are talking about data that are numerical information, something that is numerical. You are taking observations, you are taking things that give you values in numbers. They can give you, you are working with things that can be measured, things that can be counted. You are dealing with quantitative data. For instance, numbers 1, 2, 3, 4, 5, temperatures, 37 degrees Celsius, and so on and so forth. Things that can assume numbers like that. When you are dealing with all those kind of things, you are dealing with quantitative data. For instance, you count pets. You do all of those things. You take measurements. You are dealing with quantitative data. When you do all of those things, either it is continuous, either it is decimal, either it is whole number, And you see that all of these data types are things that you would have to deal with at some point in your data analysis career, right? Whether it's whole number, whether it is decimal, whether it is whatever, you are dealing with quantitative data in that case. Now, because they are quantitative, that means they take the form of numbers. That means that they can be measured and they can be counted, right? So this kind of data, because they are quantitative, now it allows that we can do some certain kind of analysis on them. That was why I was saying earlier that before you know the analysis to do on something, you need to know the form in which it is coming, right? So because these ones can be measured, they can be counted. Now we can perform calculations on them, such as looking at averages. We can look at correlation patterns. We can look at regression patterns. Those are very, very, very deep concepts that are used today in every field. Looking at correlation, looking at regression, very powerful concepts. So, but we can do all of this because we know that the data is in quantitative data. And we can also employ some other visualizations like, using histograms. Remember all those statistics you used to do back in high school? Population, they would ask you to do class interval, class width, and all of those, right? So you use histograms, we can use scatter plots, we can use line charts to display this kind of data. That's for quantitative data now. That will help you to detect any trends or any anomalies, anything that is out of place. But on the other hand, we have what we call qualitative data, right? When we are talking about qualitative data, we are talking about, it's just like the opposite of quantitative. So it's just like quantitative and verbal, right? So when we're talking about qualitative data, we are talking about data that is non-numerical. Non-numerical, I describe qualities, right? Like some characteristics, opinion, and all those kind of stuff. What you feel, what your senses can tell you. Like you have a nose, you have a skin, you have all of those sense organs, you have a tongue. Those things that you can feel from those sense organs, they are qualitative data. They can only qualify. Okay, I tasted this stuff. It's bitter. It's sweet. We are qualifying. They are saying how it tastes, right? So all of those we have as qualitative data. Strong examples include, customer feedback. Like a good example I used to use for my students is when you work with these service delivery companies, this transportation, maybe Uber, maybe Bolt, maybe some of those, right? You take a ride, and maybe at the end you are left with a form to fill, right? To recommend, to rate, to do all of those things. What you're giving is giving qualitative data. You can give them a piece of your mind. You can go to Play Store or App Store, download an app, then you can go back to go and write reviews. So all those things you are giving qualitative data. So even though you are writing them as words, there's a way they can be analyzed too. They are not useless, right? So we have all of those under qualitative data. And we have, because we know that this is another method now. There are different methods for analyzing qualitative data too. We can look for some common themes. We can do some things like sentiment analysis and do some certain kind of visualizations that are permitted under qualitative data. Like when we use bar plots, for instance, you can use bar plots when you have qualitative data. So all of those are available for us when we are talking about qualitative data. Okay, for just a minute, I'd like to check up. Guys, are we still together?
Yes, sir. Yes, sir.
Okay,
Yes,
okay.
we are
The
here.
other guys, are we together?
Yes, we are here, sir.
Okay, okay. Toby, we are good, right? I think she left off. Okay. So we have all of those. Now let's pick each of those. We talked about qualitative data, we talked about quantitative data earlier. So let's pick them and look at what we have in them, right? So when we are talking about qualitative data, we already said they can't take number forms. In fact, they are the exact opposite of they are the exact opposite of quantitative data, right? So let's look at qualitative data. Let's look at what we would have. A better way to understand it is when we are talking about qualitative, we are talking about quality. When we are talking about quantitative, we are talking about quantity. Quantity talks about numbers, right? Okay. So under qualitative data, we have nominal data. Now I'll explain what this means. It's easy to understand. Nominal data refers to categorical information that do not have an inherent order, like they lack inherent order or ranking. What does this mean? It means that, for instance, a black man is standing and a white man is standing. It is not proper to come and say a white man is greater than a black man or a black man is greater than a white man. We are all humans, for God's sake, right? So somebody could bring a pen, somebody could bring a pencil, another person could bring a paper. They are not the same thing. So you wouldn't say pen is greater than pencil or pencil is greater than paper because each of them has its own use. So that's the concept of nominal data. Things are grouped into different categories. And in those categories, there is no order. One is not greater than the other, and another is not lesser than the other. That was why I had to use the example of white and black. For instance, male and female. A man is not greater than a woman, and a woman is not greater than a man, right? So it's like a nominal, they are in nominal categories. So when you work with nominal data, you often need to classify or group them based on their attributes. Examples include gender, nationality. A Brazilian is not better than a Nigerian because he's a Brazilian, right? So they are two different things. Yeah, they're in two different categories, but you can't rate one ahead of the other. You can't say a red-haired girl is better than a blonde girl or something like that. So it's just they're just two different things. You wouldn't place one over the other. Okay. So while analyzing nominal data, because we know that it is nominal data, there are some things we can use to visualize. There are some kind of visualizations that are available to us, like using creating frequency tables or bar charts to visualize the distribution of categories. That's why I said it is key as someone into data analytics to know the kind of data you're working with. If you get to work with maybe a sales store data, for instance, where you have them selling different products in different categories. They sell clippers, they sell maybe what the ladies use to make their hair. Maybe they sell wigs. You wouldn't say a clipper is greater than a wig. You will come and say maybe wig is greater than clipper. So you have a bar chart. Maybe just have a bar for each of them. One is not better than the other. One is not greater than the other, right? So none has the right to come before each of the other one. Both of them can be on the bar chart. So that's on nominal data. On the other side, we have what we call ordinal data. So ordinal data is just like the opposite of nominal data too. Now you're talking about ordinal data. It means that things are in different categories, yet in those categories, there is a level of order. There's a level of inherent ranking, right? What I mean is, look at this example I gave here, right? We have reviews, for instance, excellent, good, bad, fantastic, okay, don't like. There are levels to this. Everybody knows that being rated excellent is better than okay or bad. In the educational system, everybody knows that a first class is better than a pass or a fail. I'm not necessarily saying that the person that left with the first class is better than the person that left. No, but then the degree now, the grade is greater than the other one. So when we are talking about ordinal data, there is a kind of order to it. Another example that we often work with is dates. When we are working with months, it's not like January is greater than September. But then January, everybody knows January comes first in the order of things. right? February comes after January, and February still has like lesser days than January. So it's not like one is greater than the other like that, but then there's an order to them. Okay, so when we undo ordinal data, okay, examples include customer satisfaction rating, educational levels. I think I mentioned that. So when we are analyzing ordinal data, we use measures of central tendencies, things like median. We use graphs like bar chart or pie to display the distribution. So each kind of data tells you which kind of analysis suits it, right? And it will be wrong for you to just use something that is out of place because you don't understand what you have. Because the essence of, I used to say that data analysts are detectives. I think I said that in last class, that data analysts are detectives. Yes, they are detectives, and they are storytellers too. Or whatsoever you detect, it is your responsibility to come back and to come and put it out in such a way that people can just look at it and they get it at once. So then we look at on the other side where we have quantitative data. Now remember, quantitative means that they can take the form of a number and they can be measured, they can be counted, and all of those. Minutes, sorry. Okay, so they can be measured, they can be counted.
Excuse me,
Yeah.
sir.
Okay.
Please, I want to ask a question, sir.
Okay.
On nominal qualitative data, what can we use to create the zone? Is it centered tendency also?
I can't hear you clearly.
Like nominal qualitative data.
Okay, nominal. I was talking about under qualitative data, right?
Yes. Are we also using centered tendency to run it?
Yes, it depends. It depends on the
Okay,
form
sir.
in which it comes there that will determine what you use.
Okay,
Right?
sir.
Yes. So that's on that. But then when we start to look at this thing, you see some of the things I'm talking about. Sorry, what? Okay, so types of quantitative data. We talked about discrete data, and we talk about continuous data. So let's look at what they are. This was the part I think it was confusing me a bit when I started analysis. I was like, okay, what's the difference? But then the concept is quite simple. When you're talking about discrete, you're talking of data that consists of distinct separate values or categories that you can, sorry, I think that was a mistake on my part there, not measure, that you can count. Just take note of that. Discrete, it means you can count. That's why if you see my illustration under, I said counted, this one can be counted, the other one can be measured. Now, when we talk about discrete data, we are talking about things that take the form of a whole number. Quantitative means it takes a number, but then discrete under quantitative means that it takes a whole number. I'll give you an instance. I always give my students. If I take you into a room and we have 10 cats, right? And maybe the 10th cat has like 2 legs instead of 4. Every other cat has 4 legs, but that guy has 2 legs. You don't say because he has 2 legs and you count the cat as 9.5 or 9.25. You still count him as a unit. You still count him as a cat, right? So that kind of data you are taking is what we call discrete data. It will always take the form of a whole number. Now, when I'm talking about whole number, I'm talking about I don't think you can count it in negative integer now. So it's definitely positive integers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. So when you are dealing with data that comes in that form, you know that you are dealing with discrete data. They will always take a number, and that is why they can be counted. I can't ask you to come and count something now, and you finish counting and you tell me you have 10.29 or 10.9. Like, how did you go about it? So whenever you have something like that that is in the decimal, you know you are not dealing with the discrete data. You are dealing with the other guy. That's continuous data. And the concept is with continuous data, it is not counted. Rather, it is measured. For instance, taking a thermometer to get somebody's temperature, that's you will get, even if you get this thing 37, it will be like 37 point something because there's a possibility for you to get decimal in that range, and it is within a fixed range. That's another way you know it. You get you don't get whole numbers. It can be measured, and whatever you are measuring is within a fixed range. That's when we are talking about continuous data. For example, a car speedometer, we are measuring like the speed. We are taking the speed for different, maybe you are dealing with, I don't know, analysis that deals with, accidents, car speed, and all of those stuff. You are dealing with a continuous data when you are dealing with speed ratings now, because it's within a fixed range. It does not go out of that range. Take somebody's temperature. The temperature of the person is not going to come out of the range of the thermometer, right? So it's localized within that fixed range. So when you're dealing with data in that kind of context, you are saying you're working with a continuous data. So it assumes a value within a defined range or a defined interval. It is measured on a continuous scale. For instance, time. Time is always in 24 hours. 24 hours. It does not change. It will not get to 25 tomorrow. So it's a continuous cycle. So it's continuous data. Temperature, distance because you could get 15 point something kilometers, and so it's not you don't count distance, you measure distance. So you don't also count continuous data, you measure continuous data. Can we get that part, guys? Hello guys, are we together?
Yes, sir. Yes, sir.
Okay. So when you're dealing with continuous data, you always measure, don't count. So if you work with people's height distribution, all those things, you are looking at continuous data. Height of people, somebody's 2.8 meters, somebody's 5 foot 5'10", somebody's, you are dealing with, still continuous. So other examples, weight, speed, and all of those, right? So because we know that they are continuous data, there are ways of working with them. There are ways of working with them. For instance, the popular example we use is that histogram we used to plot in school then, right? We have to do like age bins. We have to create like age bins, this class width to this class width, this class interval, and we have to just plot everything linked up to each other. So when you are dealing with this kind of data, you should be open to working with those kind of visualizations, like histograms, and the other ones. Okay, that's some types of data. Okay, so in a minute, let me take us to. Sorry, this is a part of my last slide, so I don't need to touch this. So let me, still on data, let me take us to what are data, the other part. So still on data, we've looked at what are data, we've looked at data types. Now we want to look at data structures. We've looked at what are data types. It is important that we look at what are data structures too. Okay. So when we talk about structure, it's basically, how things are ordered, like how things are arranged. I'm talking about the structure of a thing. It just means how it's organized, how it's built up, and all of that. So data sets can be classified into three main types, where we have structured data, we have semi-structured data, and we have unstructured data. All of these are easy to understand. Just follow the concept. right? So each type refers to the level of organization and how easily data can be processed by computers. So the three basic types of data structures, three basic type of data that we have according to structure is unstructured data, semi-structured, and structured. So from the image, you can get an idea of what is happening with all of them, right? Good. So when we talk about structured data, we'll be picking that first because it's the easiest to understand. When we talk about structured data, they are highly organized and easily searchable within relational databases or spreadsheets. Now, the concept of relational databases is database where you have there's a structure in it. You have tables that are linked to each other. I don't think I would explain all of that now. So when we get into the things we'll be doing later, I will explain more on it. But you just have to know that we know that databases is just like a house for keeping data, right? As opposed to when you have Excel. When you have Excel, you're always working with tables. But then when you're working with databases, you have multiple tables. It's like you're working on a bigger level than working with ordinary spreadsheets, right? So that's all you need to know for now about relational databases. It's more advanced than working with spreadsheets. When we talk about structured data, they're highly organized, they're easily searchable, and you keep them in spreadsheets or relational databases. Another thing is it follows a strict format, typically in tables with rows and columns. Okay. One thing is when you want to take data into Excel to analyze, you take data that are either in numbers or in words. So when you are dealing with a system like that Excel, which is a spreadsheet package, you are dealing with structured data. If you are looking at data that can be fitted into spreadsheets like that, Google Sheets, SPSS, Excel, what's the other one? Is it LIBA or what's the name? You are looking at structured data because those data can fit into tables that you have rows, that you have columns. Some of the features of structured data includes the organization. Data is organized in a predefined way into rows and columns. So there is a fixed structure to it. Everything that is going to be inside that table has to be in a row, and a column. So there is nobody that is falling out of line here. So when you have that kind of setting, we say we have a structured data. There's a clear schema or data model that defines the structure. Now, when you're working with Microsoft Excel, there's a way to work around schemas. There's a way to work around schema. What a schema means is just showing the relationship between tables. It's just like very similar to what we call data modeling. Is when you are modeling data that you show the schema, you show how a table is connected to another table, how tables are linked together. So when you're working with structured data, you have a clear order of things. Which table is connected to which table? Which table is not connected to which table? Which table can I use to access another table? All of those you can find out that it is clearer when you're dealing with structured data. Then as to the data types are always numerical or categorical data. They're always text or number values. So there's nothing strange. I wouldn't call you to come and take an Excel sheet for me. I want you to analyze some data for me, and you come and you start finding MP3 files or MP4 files or GIF files, all of those things, right? Because those kind of data are not to be analyzed in that kind of package. So there's a level of consistency. There's a kind of data type you expect in this, and they are in either numerical format or categorical format. So it is easily stored. I'm talking about the accessibility now. Easily stored, managed, retrieved using SQL or other query languages. So I talked about SQL in the last class, structured query language. So when you are using SQL, we have two different languages for querying databases. So we have what we call relational database. We have what we call on the other side non-relational databases. So both of them are different in what they do, right? When you are dealing with SQL, you are dealing with relational databases. So you are dealing with data in rows and columns, right? So that is the structure that structured data keeps. You work with data that can be fit into rows. You work with data that can be fit into columns. On the other side, where we use NoSQL, you are working with different file types that cannot fit into rows and columns. So because these ones can fit into rows and columns, they are easier to work with. They are easily stored. They are easily managed and all of that. So some of the uses is used in cases where organization and analysis are straightforward. Most of the company you see in Nigeria, I don't know, we say you should come for data analysis classes and all of those. Many of the times we're teaching you how to work with structured data, maybe semi-structured data. So it is when you've perfected all of this, you feel like, okay, I want to go a step higher, I want to go further, I want to do all of those things. You can now go and start working with the other types. So it is used in places where organizations where analysis is straightforward, like business, operations, finance, healthcare, banks, all of those. Many of those places, they only have data in tables, that is rows and columns. There is nothing different. So most likely, when you get your job as a data analyst in this country too, you are just going to be working with tables. Now, tables can be bigger, tables can be smaller, but then they are still tables. All your data are still in rows and columns. Okay. So examples, we have spreadsheet packages. I think I mentioned that earlier. We have relational databases like MySQL, PostgreSQL, we have Microsoft SQL, and some other very popular ones too. So another example includes CSV files where you have rows and columns, right? If you worked with times, even machines, when they take data for you, they take it in CSV files. So you have your data in rows and columns. So they give you a kind of structured level data. So on the other side, you have what we call unstructured data. Okay, I think I'm picking unstructured first. We have what we call unstructured data. I will talk about unstructured data. We're talking about the fact that the data does not have a predefined structure. And because it does not have a predefined structure, it's not as easy to organize or analyze like structured data. It could involve a wider variety of formats. Like I said, for structured data, you have only numbers, text, and all of those in rows and columns, which are in tables. But yeah, you have a wider variety of formats. So let's look at some of the characteristics. Okay, also because you have it in a wider variety of formats, you can't have them in rows and columns. Imagine you have maybe all these JSON files, HTML files, all those stuff. You can't probably manage them in tables where you have rows and columns. So the characteristics involve that there is no formal structure. The data isn't organized in a tabular format. It can't be because of the wide variety. It's not just numbers and text. Complexity, data can come in various formats, such as text, images, videos, or audios. So when you deal with Facebook, when you deal with WhatsApp, when you deal with all of those social media guys, you are dealing with a database because everything you say is stored somewhere, and that is why it's not disappearing as they are texting it. Your videos, your audios, your text, your stickers. For those that love to send stickers, everything. So there are different file types. You notice that the way you send MP4, you send MP3, you send MKV, you send GIFs, you send JPEGs, you send TIFFs, you send, can keep listing many of them. So the database that will handle that, it cannot be that it's Excel that is behind the system that is keeping all of those data and they are using to manage, store, and analyze it. It's not possible because those data cannot be fitted into tables, right? Another thing about them is that they have no schema. They are schemaless. I talked about schema the other time, that is just like showing the relationship between different tables. Those are not, they don't even fit into a table. There's no structure, unstructured. So there is no schema, it's schemaless. Therefore, it's more complex. And because it's more complex, when you want to analyze this kind of data, look at the analysis challenge. Okay, for the data types, it includes multimedia, natural language, complex data, different kind of files, different multimedia files. So when you want to analyze them, they are more difficult to analyze. So you have to come to use programming languages. You have to come and learn techniques like NLP, natural language processing. You have to come and learn image processing and some other algorithms for visual data like that. You know, just like you can analyze 1, 2, 3 ABC in your Microsoft Excel, analyze customer sales, analyze all of those. The same way pictures can be analyzed, same way all of those things can be analyzed, all of those multimedia files. But then they are not done using SQL, not done using Excel and all of this common stuff. They are done using programming languages. And I was talking about data scientists yesterday. So to a large extent, their work. Scientists go further into all of these things. Okay, the use is they are used in cases where data doesn't follow a specific format. I mentioned that already, such as in media, social networks, and content creation. I talked about content creation, TikTok, Instagram, LinkedIn, all of those. So examples include emails. Yeah, your email can contain text, contain videos, contain files, contain pictures, contain social media posts, audio and video files, documents, web pages, or blog posts. Yeah. Hello, guys. Are we still here? Just let me know.
Yes, sir. Yes,
Yes,
sir.
yes, yes.
Okay, good. Let's confirm that. Okay. So that's for unstructured. So when we leave that, we are coming to deal with structured data. When we look at structured data, we are looking at a mix, just according to the name, a mix. It's between what we call unstructured and what we call structured. So semi-structured data is like a hybrid of structured and unstructured data. Yes, it has elements of structure, but doesn't enforce rigid rules there. There's some level of organization when you look at it. It's not strictly in tables or relational databases. So it's just like half structure, half no structure, partial structure. Yeah. So let's see. Data will contain tags, will contain markers, or it contains elements, primarily elements that does not make it, they don't give it a clear structure for you to be able to say, okay, let's fit this into tables or columns. Example is a JSON file. That's that picture I give on the side is a picture of what a JSON file look like. The kind of, some of this it's a file type. Many of these what do they call them? We use this in data analysis too. Web development guys, they work with it a lot. So those kind of JSON files, XML files, and all of those. When you are dealing with all of that, we are dealing with semi-structured data. There's no strict schema. The schema is flexible because it's not totally structured and it's not totally unstructured. Talked about the fact that JSON files, XML files, those machine readable files, many of them find their place here. When we look at the storage, they are also stored in NoSQL databases. Yes, they are. Well, I talked about SQL the other time, but there's also what we call NoSQL databases. SQL, I talked about the fact that they are relational databases and they are used for structured data. But then NoSQL, it means that they are non-relational databases. They don't contain tables that are connected to each other. And because they are like that, they contain random files and random stuff. We use NoSQL databases like MongoDB, like the other ones. But on the other side, we would have used PostgreSQL, where you have structured data. We would have used PostgreSQL. We have used things like MySQL. We have used things like Microsoft SQL. We would have used things like SQLite and the rest of them. So the use is when some level of flexibility is needed, such as in web applications. You see, I was talking about web this thing the other time. So when some level of flexibility is needed, such as web applications, communication systems, communication and information systems, data transfer across systems, that is when this semi-structured data finds place. They are encoded in some ways. I don't know if you get what I'm trying to say. They are encoded in some ways. It's not just text and numbers that you can just see and pick up and just start analyzing. They are encoded documents. So examples include the CD files that they are listed here. They are encoded files, JSON files, XML files, log files, HTML pages. That's for web designers, and the rest of them. Emails with metadata such as timestamps and the rest of them. So they are semi-structured data. And I put their differences here. But then I think we've talked about every of these differences, right? From the fact that it's predefined roles, strict schema, relational databases, the kind of data types. I've mentioned all of this. So it's just me just putting them side by side before your face so you can look at them and clear your doubts, right? Okay. Okay, so I would stop there on data structure. I think this slide was built for another class. I just came to use it for tonight's class. It was built for another class. So I went straight into another topic, straight from there. But then I want to hear your opinion. Do you guys understand what I've explained tonight? If you have questions, if you have worries, if you have concerns, now is the time to mention them. Anything
Okay,
that's
sir.
okay.
So you talk about the relational database and non-relational database.
Okay.
They are under what?
I talked about relational databases, yes, and non-relational databases, yes.
Yes. The two are under where?
They are when you are talking about relational databases, right?
Yes.
They fall under the structured data because relational
Okay.
databases, yes, you have rows, you have columns. Relational databases, I don't know. Have you worked with a database before?
No, yes, I just read about it.
Okay, you've read about it before. Is there anybody here that's worked with a database before, like a relational database? So when we talk about relational databases, you're talking about, let me give you an instance you can relate with. You know INEC now?
Yes, sir.
Yeah, INEC is the one that is in charge of the elections and all of those. Not only INEC, I'm just using INEC because it's very common to us. For instance, they should have a database. And what will be in this database is like the elections they've conducted from the inception, from when Nigeria started having elections, right, till this present
Yes.
date. And
Okay.
That database is supposed to house every vote in every local government, in every state, in every, what do they break Nigeria down into again? They shall break
Town,
them down to
local
different
government.
levels, right? Yeah. So they are supposed to have all of those data. That place, they will keep all of those data so that whenever they need access to them, they can go and get the data. They can go and update the data when new data come for another election, right? Because
Yes, sir.
when we did the next elections, maybe 20, when is that? 2027. Okay. So when they will do the next elections, they should be able to go and update that database and put new data. Okay, oh, this is the new data, right? So that place where you can store the data, you can manage it, you can update it, you can retrieve it. It's called a database, right? So
Okay.
that's what a database means first. But then now we've agreed that data are stored in databases, Abby,
Yes, sir.
and it is unlike Excel. Yes, you can store data in Excel files too. Am I right?
Yes, sir.
But then Excel file is very limited in that it is not as bogus and as imagine that all the elections that we've had from date, all the polling units are stored in Excel files from the beginning of the country. Is it possible? Does it make sense?
No, sir.
So it's not. So that's why databases come inside. Databases are more security proven, they are more bogus, they are more larger. In fact, big organizations have to use databases, not all of those Excel sheets. So that's for databases. Then now, when we are dealing with databases, we have two of them. We have relational databases and non-relational databases. When we talk about relational databases, we are talking about databases, firstly, that has a structure. The fact that it's not Microsoft Excel does not mean that the data that is brought into it does not still stay in tables. It still stay in tables, rows and columns. So it works similar to that Microsoft Excel pattern where you have rows and columns. You get it now.
Yes, sir.
When you have that level of organization, you are dealing with a structured data.
Okay.
And yeah, those tables now, they now connect to each other. Because if you look at the INEC database now, it's still the same country. Abby, it's still the same
Yes,
Nigeria.
sir.
So all of those data, they are about the same thing. There's a kind of relationship between every table, though they are different, but there's still a level of relationship between them. Do you
All
get that?
right, sir. Yes, sir.
So that's a relational database. But on the other
Thank
side now, if you have data that cannot be filtered into tables, into rows and columns, that was where I now came to Facebook with Mr. Mark now. As it's not that if he has a database where all of this our data is going to. And that data contains text, contains pictures, contains different kind of documents that you can never think of putting in tables. Or can you put videos in Excel? Just think
No,
about
sir.
it. Even if there's a way you can put it, you can't analyze video in Excel.
Yes.
So those kind of places, those kind of platforms where you need to have different file types, where there is no other, different kind of people can just come and throw different things depending on how they feel. That kind of this thing, you need a non-relational database to deal with it, to keep those files and to be able to manage them, to be able to access them. I don't know if I answered your question.
Yes, sir. Yes, sir. You did.
Okay.
Thank you, sir.
You're welcome. Hello, guys. Anyone still have questions? Anyone has anything to say? Hello, guys. This one, we are not talking, right?
Hello, sir.
Okay,
Good
good
evening.
evening. Good evening. Okay.
Well done, sir. Sorry, I'm late to the class.
Yeah.
I mistakenly entered the link. I never knew it was about web development, so I had to exit myself and back to this.
Okay.
So I don't know whether there's a material to be provided after the class, because of the things
He
I've
said
missed.
you didn't know it's web development or what?
No, the class I entered was a link for web development.
Oh, okay. The other one you entered. Oh, so
Yes.
sorry about that. Yes, so sorry
So
about that.
when I was like an hour to it, I discovered that it was about web
It
development.
was about web development.
So,
Oh,
yes, so I now exist. When I saw they wrote something about CSS, that's why I realized it
yeah,
was web
yeah, yeah.
development. Then I existed. So my
Oh,
question is, I don't know whether after the class, whether there's a way we can get the source material for the slide for the class.
yeah, that's fine.
I,
The last class, I dropped the
yes, sir.
material. Did you get that?
No, I didn't. This is my first time. I
Okay.
didn't know they've started the class. I just saw it today.
Wow. Okay.
Yes.
So to tell you again, we started right. Okay.
Yes, sir.
So
Um,
I dropped the material for the last class in the group. So if
no,
you're in the group, you would get access
because
to it. I think someone just checked it up and she found it already. So
okay,
this
no
one,
problem.
I would endeavor to drop it on the group too.
Okay, thank you very
So
much,
you'd
sir.
have access to it. Yeah, you'd have access to it.
Thank you very much. I'm sorry for my lateness.
No, no problem.
Okay, thank you, sir.
Yeah, you're welcome. But then
Thank you.
I would appreciate because there were some other guys that were in the last class too. I can't find them in this class.
Oh, no,
And
I'll always
I'm
be
thinking,
consistent. Hopefully.
okay, okay.
Yes, sir.
I'm thinking,
Thank you very much.
yeah, yeah, you're welcome.
Thank you, sir.
So I would like to plead with us too that if for the other guys, please just make sure that you maintain that level of consistency. For those guys I noticed in the last class now, they're not in this class. By next class, maybe they feel
There,
they have
there.
more
I
free
just
time. They come
hello,
into the class. Yeah,
hello. I'm here. It's just that when I missed
I
the
can't hear
first
you.
class.
Are you far from your distance from your PC? Are you using
Okay, let me off my Bluetooth.
an headphone?
Can you hear me now?
Yeah, I can.
Yeah, I was in the public. I didn't know that the class will be holding today.
Oh, okay.
So when I realized, I just have to listen. I can't unmute myself. So I just
Okay,
got in.
okay,
I just got home. That is why. Yeah, but
okay,
it
okay.
was a
It's fine.
nice
Yes,
class. I was
but
listening.
then there were some other two or three guys. I don't know
Yeah,
if
yeah.
you
I don't.
remember.
Yeah.
That's why I'm mentioning it. So that when we have classes like this, somebody missed the next class. By the time they will come, the upper one, they might have missed some things we've discussed. And I want to
Yes.
try as much as possible to make sure everyone follows along.
Yeah.
So
I
that's
understand.
just mention. Okay, okay,
But sir, I have a suggestion. Due
okay.
to the due to the mix up in the group or something, can't we create like a special group, a mini special group for the data analytics students?
The way it is, I'm not the project, I'm not the course manager, right? So, my manager, I think, okay, he left, but he was here earlier when the meeting started. So what would happen is, maybe I would ask him, but then for now, I guess we still have to stick to that group, right? Because
All
I
right,
don't
sir.
have the full authority to just decide to just create groups out of it. So you
All
get.
right, sir. All right,
Hello,
all right,
sir.
sir.
Good evening, sir. Hello, sir.
Good evening. Good evening.
Sir, please, I would like to suggest something. Maybe you can help us
Okay.
discuss with them.
Okay.
Looking at the time when the link to this class was dropped, it was around past 6. So
To this class,
that time
right?
is like a roll.
Hello.
Sir?
The link to this
Hello?
class, right? You mentioned link to this class.
Yes,
Okay, okay,
yes. And even for many of us didn't know that there will be class today. Maybe you can help us discuss with them. We should have like a timetable whereby we know the date and the time, so that because by that
okay.
passes many people are just leaving work, and before
I
they get home,
understand.
maybe. So I was just fortunate to be on my system and just check the group. That was where I got to know that. So with that, we know the time and the
The
date
date,
that
yes.
we are going to be
Yeah,
having the
sorry,
class. So I
sorry,
Yeah,
think
sorry
yeah.
that's
about.
for that.
I think that's what I also want to make comments about. Maybe let us know it should be 3 days in a week or something like that. So we just have a fixed time that yes, today will always be for data analysis and stuff. So people can work towards that and they won't miss it.
Okay. So
That is a nice idea.
okay, to answer that. So sorry about that. I'll still apologize. The thing is, we used to organize our classes like this over time, over time, over time. So it's something we do reoccurring. And we used to have a schedule of how things would turn out. So, but then I guess it's being worked on currently, even as we are speaking. So we want to say sorry about that. But then when the class is hold by, for the time, the class is always hold by 7 p.m., right? And the reason why we put the classes for 7 p.m., all our classes that we are ever going to have are going to happen by 7 p.m. And the reason why we put the class by 7 p.m. is so that, some people, even if they've gone to work and by 7 p.m., we believe that they would have made it home, at least just to be able to join the class. And, looking at the fact that this is like the holiday period, but then I understand that some of us still have to work, right? So I would make sure that what I would do is, when the days we are going to be having our classes, I saw him yesterday on the group. He said lectures are going to resume on Monday. I saw a message like that. So I thought that, okay, you guys already knew that since on Monday, 7 p.m., which is our regular time. But then I'm reiterating that 7 p.m. is our regular time. As regards the dates, the particular dates where we would have the distance. So we would try as much as possible to get that stuff out where we know the days. And if that does not work, once I find out that, okay, the class are going to be holding today, ahead of time, we'll pass the information so that you guys have at least maybe like 12 hours or something to prepare for the class, to when you know that the class is coming ahead, right?
All right, sir.
That
That would
would
be
be
better.
that would be great. That would be great.
Okay.
Thank you, sir.
Okay. These
Thank you very
guys
much,
are
sir.
not talking at all. Yeah. Blessing. Okay, I think he talked when we started this thing, but then it looks like a chill guy. Okay. So I've tried as much as possible to this point to take the classes step by step, so that when we get into what we need to do, when we get into now the technical part, many people believe that analysis is just technical part, just using tools. No, knowing how to use Microsoft Excel, knowing how to use other tools just makes you a tool user, not necessarily have the thinking of an analyst, right? So try as much as possible to run through some of the foundations, some of the things that guide our decisions, and all of those. There are still more of them, but I wouldn't necessarily want to run through all of them. So by next class, by the grace of God, I'm hoping that we'll start looking at some technicalities, some how to get your hands on some stuff, and how to start out to do a couple of things, right? So just make sure that you don't miss the next class. Yeah, I'm still going to be start basic on that, but then we're going to start working with our opponents. If I have my way, I would get materials across to you so that you guys can do as we go. But then I understand that some people might not move as fast as we hope. So at least you would have the material to practice with, and the videos on the IT skills YouTube page to watch later, and to practice with. So I'm leaving you here. I'll say have a good night rest, everyone.
All right, sir. Thank you, sir.
All right. Thank you very much. Good night
Please,
to
the
you,
last
sir.
question. Please, last question.
Okay,
Last
okay.
question.
Okay,
I asked
sorry.
a question. I asked a question in the last class, but
It's
Okay.
a
you
question.
didn't. Yes. So I asked about like the tools that we are going to be lecturing
Sorry,
us
I
on.
can't hear you.
Hello,
You
can
asked
you hear me?
about. You said you asked about something. Yeah.
I said I asked about the tools, Excel and Power BI, and I just want to know the tools that we are going to be working on, like in the technical class.
Okay. Yes. The thing is, it depends on how we pick, but then we are going to start up on Excel. So let's see how far we are looking at during this holiday. I don't know, because I'm not the manager. I'm not the one to determine when the classes will end. But then we are going to start on Excel first. I think if you want to do anything on like data analysis, you wouldn't necessarily want to start. I understand that maybe you might be worried, maybe because you have some experiences before, you were expecting that maybe we'll start with maybe some programming languages or something. But then we have to start as basic as possible so that everyone can be on the same page. Then we'll see what happens from there.
Thank you, sir. Thank you.
Okay. So have I answered everybody? Okay. So I think I have to say good night here before you people remember other questions.
Good night, sir.
Okay, yeah, good night, good night. Have a good night rest, everyone.
All right, sir.
See you too, sir. Thank you very much.